All right, that seems to be working. Trying to get my chat up here. All right. So confirming, can you confirm you hear me okay? I think I may have stepped away for a second.
Yes, yes, we can hear you.
All right, appreciate it. Thank you. Just making sure. Um, so, at any rate, using SSL. This is something that is near and dear to my heart with my bit of experience working in the security realm. Um, it is something that I find is not used and not discussed nearly enough around DBAs, and that's not an Informix specific one, that is globally. A lot of us, especially those of us that have been administering database systems for a long time, we may have been burned by trying to implement SSL in the past. So I'm going to hopefully demystify, make you focus on it a little bit more, and hopefully this will kind of walk you through the, okay, how can I set up SSL? Um, I will promise this will give you a base, this talk will give you a basic, step-by-step on setting up SSL in your environment. Promise it's not too scary. It'll be good. Just trust me when I say do it. So let me show you why. Before anything else, I want to really emphasize why this matters. So there is a tool, you can go download it right now, called Wireshark, packet sniffer. Put it on your desktop, put it on an Informix dev server, what have you, and take a look at what you see. So this is a live connection from my desktop to an Informix server. And I want you to take a look in the bottom right-hand corner here. You notice the little SQL exec name Bob-P, then a password? That's what's going through the network right now. When you make a connection to Informix on a SOC TCP connection, this is what's going. Auditors don't like this. You don't like this. Nobody likes this. Well, other than the people trying to sniff your packet, they like this. So, and then, you started your connection, you go in and you do a select statement. Oh, hey, that's in plain text too. And then you go through, oh, hey, the return data, plain text too. Let's say you're dealing with some PII data. Great. You may have implemented, encryption at rest. That's fine, but we're still now sending this data through clear text on transit. If you have anybody that is monitoring your traffic at any point between your start and end, they're able to see this. This is data that is out there. Right now, many organizations that I see, this is the case for. And this is how all of us have been doing this for a very long time. And unfortunately, this is no longer safe in the way of the world. And again, we'll have to pass security audits or meet other requirements, and this generally doesn't. So we're going to talk a little bit about this. So we're going to talk about what actually encryption is. I promise there won't be much math. I think I just showed why we want to use Informix, but I'll talk a little bit more. Then we'll talk about how to actually configure it. I have information here. All of my examples are up through 14. I don't have any 15 pieces, but I don't believe anything has really changed there. And then the big one is, if you saw my older ones, I didn't really cover this much, but I really want to highlight using an external certificate authority. I think it is becoming much more important for the management structure and also making your security, your security team happy. So what actually is it? If you haven't worked with encryption, this is just kind of a nebulous concept. What it does is it breaks your data into pieces and then actually uses all kinds of really hard math to make it so that only the sender and recipient can see this. A couple of different ways. Some are shared keys. Some are what's called PKI, which I'll cover in a minute. But at any rate, there's a lot of different ways this can be implemented. The CPU is used to actually do the encryption, to actually encrypt and the decrypt. So there is some more CPU involved with this, and you can really configure it for whatever length, which I recommend talking to your security team for what their recommendations and policies are. Art just mentioned something in the chat, which I really want to highlight, is when you're storing data in the cloud, that is yet another place where you're going to have end-to-end communications. Even if you're going, AWS EC2 container to, some other container, there's still going to be a network hop there that is probably going to be sending that data unencrypted. So there are so many places that the data may be exposed that really it just gets more and more important. So PKI. This is the most common way. This is what you will have used more than anything else. Pretty much the entire web runs on this, where you have two parts of a key, the public and the private. The public key anybody can have. You go to https www.wag.org. You will request the public key for that site, and you can then make any request you want. You'll encrypt it with that public key, send it to the server. The server's got its own private key. This is private, hence the name. Only the server has it, and it'll take that data and then decrypt the request you have sent, and it'll validate that not only is the data encrypted, but it also validates this is legitimate. It's using a real key, not somebody trying to spoof it or anything else. And then when it sends data back, it uses its key to send, encrypt the data. You know the public key, and it's able to then send the data back encrypted. So end to end, if anybody's sitting in the middle, everything's encrypted. Everything, you wouldn't be able to sit in the middle and just sniff the traffic. It's just going to come through as gibberish. The other term here is a certificate authority, referred to as a CA. So this is, if you've worked with it online, DigiCert, Let's Encrypt, Network Solutions got their own. There's a whole bunch of general certificate authorities out there. You pay them some money, they give you an SSL certificate, and they sign it as this is legitimate. And when your web browser goes out there, it goes to the certificate authority or more information, the information from the certificate authority to validate and get the key needed to connect. So that's kind of the public way. We all deal with this every day. Anytime we're browsing the web, we're using PKI. So how Informix uses it. So the server, we've got our own certificate, and when a client connects to a server, it'll go in and tries the connection using the key it has. The server will send the digital certificate to the client, which will then verify it. So if the keys don't match, you'll actually get a big error in Informix, but it won't create the connection. So you can't have somebody trying to fake it or give an invalid key or something like that. It has to be valid that both sides are familiar with. The big thing, though, is step 3, is when the initial encryption is validated, that it goes, all right, we both know each other, we both have the correct keys, etc., that the data is then not sent using that key. The server itself will create a one-time use key pair that it'll send to the client automatically. You don't have to do anything. You don't know this is happening under the covers. It's some really clever stuff. But everything else after that point is using the single one-use key. So even if something were to happen to have somebody be able to intercept and, break in to steal the key from the server, it's not actually going to do them that much, because yes, you'll be able, they might be able to get that initial packet, but after that point, everything you're sending back and forth is using this entirely separate key pair. So you'd have to actually start, sniffing, far deeper into the system. And if somebody has that access, you probably have larger issues. But for anybody sitting in between the two servers, this is going to be data that they are not able to access. And so again, it is a single use. So it is very secure that way. So why is it important? Again, sniffing passwords. It was purely plain text. It also validates that you're connecting to the real server. Things that mess with DNS entries or otherwise, sit in the middle and pose to be a server, those exist. And this will validate you're connecting to where you think you are connecting. We all store sensitive enough data in our Informix instances. Every little bit of validation that yes, everything we're doing is correct, the better. So the other thing is a lot of places have regulations now that any data transmitted to and from databases, especially if they have PII, require encryption. So we want to make sure it's there. And again, it does it the entire way to and from the client and the server. It doesn't matter how many hops you go between. If you're coming from across the world, this will still encrypt it every single step of the way. So number one, or one of the main reasons is auditing. Not sure if all of you or most of you have had the fun of going through security audit. They're lengthy, they're stressful, they're time consuming, and if you're not running encryption, I promise you're going to get a red flag on that one. So some consideration. When actually implementing for Informix, you're going to have some extra setup. Just like with anything else, you're going to have to create the keys. We're going to go through the whole steps on that. There is going to be additional CPU overhead, both on the server and the clients. We have done some benchmarking on this. When we were benchmarking old systems, these were specifically 11.7 and 12 on old HP Itanium systems. That was just the ones we were working with. We were seeing 25 to 35% overhead. Connections took longer to initiate, data transfer was slowed down significantly. It was pretty painful. We then benchmarked it on modern Intel systems. And when I say modern, I don't even mean like the latest and greatest, $1 million system. These were 7 and 8 year old Intel Xeon, silver systems. These weren't the top of the line anything else. And we were seeing about 3%, between 2 and 4% overhead. Reality in the real world, it was negligible. Even on multiple connection attempts, it was going from, I think it was maybe 5% difference on extra time creating a connection. We saw far more of an impact on just normal time differences with DNS lookups. So it isn't really that bad as long as you're not completely CPU starved. The second thing is it may not support older connections. If you've got CSDK 2.7 out there, please just go upgrade. I understand sometimes you can't, but please go upgrade if you can. If you're running ADODB, if you're running some of the third-party drivers, they may or may not support it. Another thing to keep in mind is certificates expire. So when you issue the key pair and create the certificates, you give it a expiration date for the key. If you're dealing with a website, it's gonna, generally it's either a year, some of them are even 3 months. On the Informix side, you may choose differently because you're not dealing with public infrastructure and you're dealing with cases where it is going to create a single-use key every time anyway, so you may want to change it. A lot of it also will depend on your security policies in the organization. There, you also be able to choose your key size. So a lot of times you'll see these as 1024, 2048, 4096, etc. The longer the key, it takes more CPU, but it also means that the encryption would be harder to break. Computer CPUs are getting faster. So it all depends on your company's policies. So again, what supports it? Our ODBC, our JDBC, our SQLJ connections, DRDA and SQLI support it, our ESQLC supports it, DB Access supports it, our replication supports it. So you see everything pretty much supports it that we'd be wanting to use in the Informix infrastructure. Connection Manager in particular supports it. There's some extra steps. I'm not going to go into all the Connection Manager setup today, but you can set up Connection Manager either to do a pass-through or actually if you're dealing with legacy applications, you can connect normally to that and then pass the rest of the way encrypted. If you're doing distributed queries, you can do it encrypted, and PAM will play nicely with it as well. So in most environments, this should be pretty simple drop-in. So We're going to talk about GSKit and OpenSSL. IBM, you've probably seen it during installs. It installs the GSKit. So, and it's not just Informix. A lot of the IBM products, DB2, WebSphere, some of the others, all use GSKit. So it's kind of like the IBM standard. So it'll give us all of the SSL, TLS communication pieces that we're going to need. The main command is GSK 8 CAPIC MDB and an underscore 64. So you see that referenced. If you're running a really old legacy version like Informix 11.7, you'll see the GSK 7 version. It just depends on your GSKit version. So a couple of pieces of terminology. The key store is our little tiny database. It's one file. This will be all of our keys, all our certificates, our public-private keys that we have installed. We'll be dealing with a couple of key stores in this process. A stash file is going to be a small secured file that will decrypt the key store. If you don't have the stash file there, you'll have to actually put in a password. Whether you want to use a stash file or not is infrastructure specific. Some places may not allow you to have it. And then a certificate file, you may have seen these at some point. It's 20 some odd lines of what looks like gibberish with like public key start and public key end at the top and bottom. That is the actual key itself. The certificate itself that will be then used to install the keys into the key store. So putting it all together, we're going to go through configure server, add the listener, create the key stores, and then set up the clients and then test it. So this is kind of the step-by-step, where if you're wanting to implement this at your office, just start at this point and just kind of go slide by slide through this. So the big thing is make sure GSKit's installed. This will install by default when you install the server or the client. That said, if you are somebody that sets up new servers by just tarring up the Informix and copying it over, it will not be installed. GSKit are actually system level libraries. So there's a GSKit directory under the Informix that will actually have the installer. So if you need to install or reinstall it, just go in there and run it. We're going to update our onconfig, SQL hosts, and we're going to create our key stores and then bring it all online. So onconfig changes. Here are the main ones you need. The first one is there's a command or a line SSL key store label. So this is the actual individual label for this particular server. In our example, I'm going to use IFX_encrypt. This can be whatever you want it to be. The second is the net type. So we're actually going to add a SOC SSL listener. So this is the same as you might add SOC TCP. It is the resources you're giving to the listener. Obviously, the tuning here depends on your environment. Our VP class. So we're going to want to make sure we add at least one encrypt VP. And then next virtual processor. And we may want more than that depending on what our load is going to be for encrypted sessions. And then we're going to add a new DB server alias. So this will be for our SSL listener. I recommend, even if it is not public, to not make the system exclusive to SSL. Always have a normal TCP or at least a shared memory connection. So I will say add this as a DB server alias. So next thing is update SQL hosts. This is not anything terribly new and different. So we have our SSL listener name, so IFX server SSL. Rather than ONSOC TCP, we're doing ONSOC SSL. Then we give it the IP address and the port number we want to run as. A lot of times you'll see 908889 used to pair with 9088. But really, as with anything else with Informix listeners, this can be whatever you want, just depending on your environment. So the key store. So I'm going to say we're running this in the Informix SSL directory. So we're going to be using the GSK 8 CAPIC MDB_64 command for all of this. And with the server, everything needs to be using the GSKit to create the keys. On the client, as Carlton mentioned the last talk, we can either use GSKit or OpenSSL. I'm going to go over both. So again, our DB server name is IFX server. So note that the server name and the alias are different. So IFX server is the actual DB, primary DB server name. I'm calling IFX encrypt for the key store. The big thing here is when we're creating it, the DB server name is the file name we are looking for when the engine comes online and starts to try to bring up the encrypted listener. It'll look specifically for the DB server name .kdb or .p12 file. So to create the key store, and I go through and I try to get the flags out here. There are different ones you may want to use depending. So we're going to run the command with -key db. So we're actually telling it to use a key store. We're going to add the -create. So we're telling it to create -db, which will tell us the file name. So note that here we have ifx_server.kdb. So it's actually creating the file of that name, which is our DB server name. PW and then our password. Please don't use password. Dash type, so CMS. So this is our certificate type. Normally CMS will be our standard, and --stash will tell us that we're actually going to do a stash file for this rather than prompting for a password each time. So next thing we're going to do, so now with that creation, we have created their key store. It's just a flat key store sitting there. It's got nothing in it. The next thing is we're actually going to create the certificate and create the key pair. So we're going to do -cert, -create, and then -db. So it is our, the same file we used before. Then we're telling it to stashed on the second line, then label ifx encrypt. So note this is the same label that we used in onconfig for the SSL encrypt name. We're giving it the size. Are we telling it the default certificate? So most cases, if we're doing this fresh, that'll be yes. The next one we're going to get it is expire. So this is how many days is the certificate valid? This is something where it will depend on your organization. Best practice is you do it for 1 year. That's what a lot of things will standardize on. However, it means that you're going to have it updated. Every year you're going to have to deploy new keys to all of the systems. If you're dealing with a lot of remote clients, this can get real painful. I will say, and again, I'm not recommending this, you can set an expiration of 20 years. Each connection is going to have its own standalone piece. It's not going to be publicly available, at least hopefully is not. Hopefully your Informix instance isn't available to the world directly, but if you set it to a longer time, it means you don't have to think about it. If this expires, your connections are going to stop. So take that what it will. My recommendation is 1 year. You can go longer. I'm leaving it at that. And the last thing we're giving it is the DN. So if you've worked with LDAP in the past, this should look familiar. So this is a particular name for this server. This can match other parts. It's probably best to match it to your DB server alias, but it can be unique if you want it to be. So when you're actually looking at certificate information, this will show up there, so it's easy to identify. And then the rest of the flags here. All right. And so at this point, we'll have two files, ifxserver.sth, which are our stash file, and .kdb, which are key store. We want to make sure these are both owned by Informix and set to 600. So these are our private keys. These are the keys to the kingdom. We don't want anyone else having access to this. So now we're going to set up a client. So we're going to do the same thing where we're going to create a new key store. We're just going to call it CLI KDB. This can be whatever you want it to be. Again, we're giving it a password. This does not need to be the same password you set up your server with. And so we now have client key db.kdb and .sth sitting in the directory. And what we need to do is now get our public key from our server. So we're going to go back to our IFX server key store. So this is our server key store. And we're actually going to call it cert extract. So we're pulling out the public key certificate, and then at the end there, we're giving it target ifx server.cert. It'll create a new file of that name. Note the password here is the server password. So all of this is pulling it from the server key store. So now we're going to take that key or that certificate we pulled from our server key store, put it into our client key store. And so we're doing cert add, telling it to client key store, stashed. We're giving it our label, which is the label we used earlier. We're giving it the file name and telling it the format is ASCII. You can go read the cert. It's not going to do it, be terribly useful for you, but it's there. It's a plain text file. You can cut and paste it if you want to go to a new location. For a client key store, because these are public keys, there's not private keys in there, you can give wider access. A lot of places will give it, 664 or 644 to let anyone on the server be able to make use of this client key store. Your environment may be whatever works best for you. So the last thing we have to do is create a new file in informixstir/etc/ and we got to call it conssl.cfg. This is a really important file. It does not exist by default. You have to go manually create it, and you want to make sure it is readable by anyone on the system. You want to make sure it's 644. So we need 2 lines in it. That's all we need. Our SSL key store file and our SSL key store stash, or STH. And we just give it the full path to our client key stores. What this is doing is any utility that is using the standard Informix stir will look for this file to be able to figure out where the client key store information is. If this file is not there, when you try to connect, you'll get a kind of obscure gskit bad key file, I think, error. So always check this first. Make sure you've spelled it correctly, that the paths work, that the user you're trying to access can access this file as well as the 2 client key store files. This is probably the #1 step that I see people accidentally miss, so that's why I'm highlighting it really hard right now. So final step. So the next thing we're going to do is bring up the engine. So either stop and start the engine, or if it's down, bring it up initially. The big thing here is you cannot use onmode-p to start an SSL listener like you can with a SOC TCP one. So you do have to bounce the engine. The engine also will fail coming up if it does have a problem with the key store. So it's a pretty good way to make sure you have gotten all the pieces together. And the next thing is just use DB access. Make sure you can connect cleanly. And then you now have that certificate you've exported, and you can go put that on any other clients that you want to deploy this to. So checking the server now that's come online. During the online log, when it's coming online, you'll see the SOC SSL listener thread succeeded. If you're on ONSAT-G NTT, you'll see a SOC SSL listener going. It's standard checking to make sure the network is up and running. So once it's done, you're going to sleep, because now you can get your auditors off your back. Your data is encrypted. Great. That was it. You now are running SSL. That is all of the steps. It was like 5 slides. Takes you probably initially 10 minutes or so. I mean, if you start messing with the settings, much longer, but it really is not that big of a lift. And that's why I really try to stress this, that even if it's going to take a while to figure out how to deploy it to your systems, figure out some of the other structures, at least take your development environment, spin this up, have your listeners there, and then start working with your development team or your application team or whoever else to start working on porting over and testing it to make sure it works. Don't sit on this. Don't wait until the stars have aligned. Go and set this up. I promise, take 30 minutes during some downtime where you don't want to deal with whatever meeting you're trying to be on, and set it up. Cannot stress enough how important this can be. So setting up a Windows client now, and I do want to actually adjust one thing that came up in the comments is if you're running 2 different versions of Informix, they may have different versions of the GS kit. You want to make sure the latest GS kit is there, but you might have problems initiating everything if you're running with different GS kits. What I'd recommend you do if you're having to run multiple versions of the Informix server on the same box is create the server key store on whatever the lower version is and just give it all the settings you want, and then use the GS kit on the higher version of Informix, or that came with the higher version of Informix, to then install it for the top one, because you do not necessarily need to create the key stores on the box they are going to run on. So that would be my recommendations. A lot of times between similar versions of Informix, it'll be the same, but they do periodically update the GS kit. I know FC11 just had a big bump to it, which is actually causing people some problems where older client key stores may need to get refreshed with it if they're using TLS 1.1. So just be aware the GS kit version does matter. And also a follow-up one is 14.1 will start if there's an issue with the SSL, so it doesn't necessarily break it. I have seen cases where it does fail, but I think it may be a 14.1 XE something. But always verify when you're starting up a SSL listener for the first time that it does actually come online before you start going down the path of trying to debug everything. Just make sure it's listening. So setting up a Windows client. So we've now got the server running, we've got our local Linux system running. Let's get our Windows client up. The big thing is creating a directory where the key store and the stash files can live. You can put this in your Informix client SDK/SSL. Some clients, I will often do this as C:\SSL. If you have something where you have automatic deployments of an application, you may actually want to bundle the SSL, your key store into the application, and then that way you can actually push out changes if you need to with the client key store just with an application launch, rather than having to have any of your other teams get involved to push files out to the servers. Again, environment dependent. For this example, I'm just going to use C:\SSL. So just like with the Linux version, we need a con SSL file. This goes into your Informix client SDK directory /etc. Note you do need administrative access to write to this directory, so just be aware of that for deployment reasons. If you're running multiple versions of the CSDK, it needs to be in all of the directories. So Windows plays pretty nicely with multiple CSDKs. Just make sure it's in all of them. And just like the Linux side, it was, same thing where the SSL key store file, you give it the same pieces. What I have noticed, and they may have fixed this by now, but when I last tested this, it did not like spaces in the file. I had to give it, DOS does their own little short naming scheme for 8 characters with, tilde, 1, 2, 3, 4, etc. I did, when I was giving it paths that had spaces in it, I did have to give the DOS notation. Maybe fixed by now, but I just flagged that as something to be aware of. So generating our key store. So again, we're going to take the IFX server cert file that we pulled from the Linux server. We're going to go through, run our commands on the command line. So add our GSKit directory to the path if you don't already have it. So make sure you can run your GSK 8CAPIC MDB_64. So make sure it's in your path. And the commands are the same. So we're going to run that, create the key store. We're going to run it again to add the certificate. So just like on Linux, it'll create the KDB and the .sth file. So just make sure that these files exist from the con.ssl.cfg. So Windows connection, we're going to create the ODBC connection as we normally do. Make sure when you're configuring it that the protocol use ONSOC SSL, not ONSOC TCP, and we give it the port and the DB server alias of the SSL listener. So just triple check yourselves and then test it. The other cool thing is key stores are not operating system dependent. you can take a key store you create, the client key db.sh and .kdb from a Linux system, throw them on a Windows system, and you're good to go. They will work across the systems, no problem. So OpenSSL. So this came in the client SDK 4.5 XE4. So as Carlton mentioned earlier, when you install the client SDK, it'll give you the option of GSKit or OpenSSL. So if you choose OpenSSL, this is what we're going to go with. This is the standard out there. 90+ percent of Unix systems will have OpenSSL installed. It is like the universal standard on this. A little easier to use if you're doing anything custom with it. Ton of documentation out there about it to do just about anything you need. You don't need GSKit installed. So if you're running multiple client SDKs, or you're running other pieces, or maybe you're just running with just the JDBC driver and none of the other pieces, you don't need GSKit installed in the system. So to actually enable it, it's going to go through same process effectively. We're going to create a private key pair. We're going to grab the certificate. We're going to create a key store, which is .pem and p12 with OpenSSL. So stash file, and just kind of go through the whole steps. So with OpenSSL, we're going to actually go in and create the key store PEM. We're actually going to go through, so these are all the steps. I'm not going to go total dry run. Notice here the days, 3000, that's the same as expire. And we're actually going to go ahead and create our server keys using this. It's P12, so this is the same and will be usable by the GSKit. I'm just showing you how to create the server certificates using OpenSSL. You can create it with GSKit and get the certificate the same way. With the OpenSSL, by the way, it does not create the stash file by default. You have to use onKstash in the P12 file you've created and the password, and then it'll create the stash file for you. So same commands. I'm not going to read through them directly. They're here for reference. Our OpenSSL config, and I kind of do the example here where we're creating the server key store, we're stashing it, and then we bring up the engine, and then we see that it's using the SOC SSL listener, 9098 in this case. So for the client, this is more likely where you'll use OpenSSL, is we're going to go ahead and create it with a pkcs12, so it's a .p12 file. We give it a password. We're going to give it the key store label .cert.pem, which is what we're going to end up calling this. And then we're going to, we do that on the server, copy it to the target. And then on the target, we're actually going to do OpenSSL. And then it's a little weird. We're actually going to call export out and then the client file. So export in this case is actually creating the key store. We give it our password from above, or actually, sorry, a new password for the client key store. We give it then that cert.pem file we created above from the server, and then we give it the CA name. So this is the server name we have used above, and then no keys, so it's using the stash file. We're going to onKstash it again to create the SDH, and then we create the con SSL conf, and then we give the client files writability. Again, I'm running through these a little quickly, but it's a bunch of commands you can go back and reference. So that's all we need to do. At this point, we changed the con SSL, and I just realized I have a typo. I'll fix that. Con SSL.cfg, not conf. But we tell it to use these client P12 files rather than the KDB files we did on the GSKit example. So using external certificate authority, this becomes more important if you are dealing with a lot of servers or a lot of clients. It allows you to have a single authoritative source, hence the name, that manages the keys. And that all the clients will be able to trust this source against it as authority, that this is legitimate, the keys it has generated are legitimate. There are a lot of different, if you want to spin up, hopefully your organization has one already. If you want to spin up your own, there are a ton of open source ones out there, a bunch that'll run as Docker images or virtual systems. You can go play with today. I'll show you the one, you'll see references to the one I used here in a moment. You can go and pay for DigiCert or Network Solutions or one of the paid ones out there, but you're going to be paying a whole bunch of money and you really don't gain anything over having a locally hosted one, because you don't have clients that are going to be validating certificate each time. So it doesn't need an external source like you do with a web browser to authenticate every time you make a connection. So how are we actually going to do this? End to end. So just like before, configure server, add our SSL listener, create our server key store, but here's where it's different. We're going to, rather than creating the key locally, we're going to create a CSR, which is a certificate signing request. We're going to send that file to the certificate authority, and we're going to get back two files. One of which is the key that has been generated from the CSR, and the other is going to be the certificate authority's own certificate. So we're going to have both in our key store. So they work in tandem, where our key goes to the certificate authority's key to validate it. And then we create the client key store, and the difference there is rather than importing the server certificate, we import the CA certificate. So in our example here, called the Informix server, Informix 4, our primary listener is Informix 4, and then the SSL is _SSL. Our key store label is test SSL label, and the password, I'm just going to call it my password. Again, please do not actually do that for your password. Set it up. So we're going to create the key store with GSKit. Again, you can do this open SSL if you want to, just like we did earlier. And then rather than doing it with generating a key, we're going to create a CSR. So you'll actually see this -cert request flag, and then we're going to tell it all the information. The big one we're also adding is the -dn. So this is the unique identifier for this piece. We're telling it the SIG alg, which is the algorithm to use. Again, your organization may define this. SHA 256 is one of the standard. And then the target is going to be a .csr file, so certificate request. And then you'll go to our certificate authority. And we go in there. I don't want to go through the steps on that because everyone is a little bit different. But just trust me, you will give it a CSR file, click a couple of buttons, and it'll kick back the key files, the certificate, and the chain certificate. So we've now have those two files coming back in. The first thing with GSKit is we add the cert, just like we did with the client key store. We're doing it with the server key store in this case, and we're importing the management chain file. So again, this is what tells all of the other trusted keys that this is how we actually go in and validate the keys and where they're coming from and everything else. Again, bunch of math involved here. I'm not going to go into deep dives. There are whole college level classes about how PKI works. The next thing we're going to do is actually do a certificate receive. So this is where we get back our certificate, which would be in .pem format, from the certificate authority and importing that. So at this point, we have two key certificates in our server key store. So again, this is what it looks like. You can use GSKit cert list, and it will actually show you the certificates. So I'm using EJB for my own example. I just had this spun up as a Docker image just to, for proof of concept. Which will return back its own DN. In this case, it's this big long one It's actually longer than I actually truncated it somewhat, but it'll be a big whole long string for the certificate authority's trusted certificate. And then the second one is our own internal server-based certificate that we had before that now the certificate authority has signed and sent back. So again, the CN is that big long string for the certificate authority. Now the client key store. So I'm going to use OpenSSL here because I like it a little bit better. And the big thing I'm doing is the first part is I'm going to import the management certificate authority cert. So I'm giving it the no keys in and then giving it that PEM. The CA name, so this must match what the server had for the name here for the CN. So it knows what it's expecting and how it to associate. I give it whatever my password should be for the client key store and then output a client P12 file and then on case dash it. Notice that's it. Notice I did not import a server key. All I imported was the chain key. So, OpenSSL, just this is the quick version if you need it. And again, that's it. So you can have multiple server certificates onto a single key store. So be aware of that. You can use the same client key ring. Make sure anyone that's connecting, again, the permissions on the key store and stash files. And if you're doing server to server communication, you need the server certificates in each server key store. I apologize, this one got out of notes, out of order. I'm missing a slide. I will get it added in. But at any rate, I'm going to jump back to the certificate authority here because this is where I'm missing a slide. I will add it in before this goes out. Is we've now imported to the client key store the certificate authority key, certificate. That is the only thing we have added into it. At this point, it just works. I don't have to import a particular server key. I don't have to worry about anything else. I could have 15 servers that have all been authorized and have the keys created from that certificate authority. I don't need to touch my clients. Clients already trust anything coming from that certificate authority. So any servers that come online that I try to connect to, I will use the chain certificate authority certificate to authenticate. It'll go through, does the validation at that point. I don't need each client or each server, I should say, to have a different key in the client. So this makes it much, much easier to have a key store that'll go out to many clients because you won't need to change it. As long as you've got your certificate authority working, you can go and deploy it as much as you want to with as many. You can expire certificates, reissue them, etc. You don't have to have new rekeying anytime there's a new key store every time there's a change to one of the servers. So again, certificate authorities are a big deal. It depends on your environment. If you've got one application, one web server, one Informix server, probably don't care. Use the self-sign created, move on with your life. It's not worth the effort to spin up the CA just for that. But if you're dealing with a complex environment, especially if you're dealing with a bunch of servers, and even more so if you're dealing with a lot of different clients, this can make your life much, much easier. So a couple of other alternatives. So you can't run SSL for some reason. You're running a CSDK 2.7 for some legacy application that doesn't allow you to upgrade it. You're running ADODB. You're running some, any number of other things that just you can't run this for some reason. I understand sometimes the environments just limit what you can do. One of the big ones is just having permanent VPNs. VPNs also encrypt the data. I'm sure you've seen 5,000 ads for Surfshark. And it really is for end-to-end from the point where it leaves your computer until it gets to its target. It's encrypted. If somebody is sitting in the middle, they're not going to be able to decrypt it. If somebody is sniffing traffic on your server or between the endpoint of that VPN and the Informix server, they will be able to see it because it's not encrypted until it leaves your computer. Another way to do this is if a VPN is not an option, is you can actually get very creative with SSH tunnels, including setting them up to do on-demand, port forwarding, etc. And actually you can set up, and I've seen this done in a few places, SSH connection almost like a VPN where you connect on demand, you've trigger set up so that it connects to the Informix server, creates an SSH tunnel between the two, and then sends all the Informix traffic through that. It's not ideal because it takes a lot of setup, but it is an option if you have none other. At least that way you'll have the data encrypted. There is a SPWDC-SM, Simple Password Communication Smart Module. If you dig through the docs, you'll find out about this. This is an old piece of technology. I do not recommend it, but it will allow you to encrypt the password at least, but you still will have data transfer being unencrypted. Having a mixed environment of the above, great. You know, having encrypted data from an Informix level SSL encryption and then having it still go across VPNs, great. You're not going to lose a whole lot of performance, and it just is one extra level of protection plus one extra thing you can check off when you're doing that security audit. The other one is you can just hope the auditors don't notice. Really, really do not recommend this. But I have seen that play out in the past, but eventually they will notice. So there's an article that came out for converting from GSKit to OpenSSL. So if you've been working with GSKit and you're now wanting your clients to go onto OpenSSL, there is a guide for how to do that. We do XDB systems, we do consulting and support. So this is kind of the overview again, and I really want to stress this because I know I went through a lot of very dry information here, but going back to it, I want to point something out here. Okay, we create the key store, create the server certificate, two commands. We set up the client key store, we import the certificate, create the conSSL CFG file, we bring up the engine. That's it. We're done. Promise, really doesn't take that long to get this going. It'll also work or it doesn't. If it doesn't work, you'll get GSKit errors, which I'll be honest are not the most helpful. There's a lot of Googling involved and going down some rabbit holes trying to debug those. If you start hitting GSKit errors, just go back and review your steps. Oftentimes you've forgotten a flag, or more often than not, the permissions are wrong. But promise, it really is not scary. It really doesn't take a lot of time, and you can run it alongside your TCP. You don't have to have everything suddenly go to SSL. You can just have this sitting up as another listener and slowly, test it and then migrate stuff over to it, one part of your environment at a time. So you don't have to do a giant cutover at once. I really, really want to stress this. Just getting it set up, try it on a lower environment, really will make your life better. And again, once the auditors come in or your security team comes in, you go, yep, I'm doing that, go along with life. So at this point, questions? Okay. So one other thing I'm going to mention, which I alluded to at the start of this, and I actually have this on my to-do list later today, is apparently with FC11. I don't know this is the case with version 15, but my guess is it probably will be. They did some updates to GSKit, so it no longer supports TLS 1.1. This is a good thing. TLS 1.1 is not terribly secure. I believe it's been delisted as a valid TLS option. This is one of the levels of encryption that Informix can use. Most everything is standardized on 1.2 and moving to 1.3. But what this means is that some client key stores that were created with 1.1 being enabled, um, then they don't work. You'll actually see a GSKit error when trying to access them about, I'm trying to remember the exact flag. It was security something not authorized. And what we found is we had to actually recreate the client key store to have it play nicely. So I just want to flag that I'm seeing that right now. I am going to be testing it this afternoon. If there's anything I find past what I just said, I will include it in the slide deck when this goes out in a couple of days. So um, again, if you're going to FC11 and you've already running SSL, just be aware of that. Any other questions? Okay, great. So again, going to the end of the slide deck. I'm sure there's a quick key to do that, but Tom at XDB Systems. I'm also Tom at IEG.org. So certainly reachable if you have questions, reach out. I'm trying to get more content out about this. I put up on the WAG site, on the, I mentioned earlier on, there's the new tech tips section. So these are short articles. I do actually have one specifically, and a lot of it ended up in this, but it is the quick cut and paste version of the setting up an external certificate authority using OpenSSL for the client. So if you want to get more detail and some longer strings for what to look for, it's on there. So information is out there, but I just really want to stress this is like one of those big things for me is start getting this in there. I don't want clients to be running insecure, and I don't want people like going in and thinking Informix isn't a secure system, because it is very secure. This is very strong and very well established levels of security. We just all need to be better about it. So thank you. I'm going to go ahead and stop this. So for those of you that are, let me finish the recording here.